All right, ready to dive into some serious Earth history.
Always.
Okay, so picture this. Two massive asteroids, way bigger than the dinosaur killer.
Oh.
Yeah, slamming into Earth. But here's the twist. No ice age, no mass extinction.
No way.
It's like the planet just shrugged it off.
That's wild.
We're going to explore how scientists figure this whole thing out, this cosmic puzzle,
Yeah.
and what it means for how tough our planet really is.
It all starts with a couple of huge GE craters.
Okay, where are we talking?
We've got the Papagai crater in Siberia
Got it?
and the Chesapeake Bay crater right here in the U.S.
Wow, I never even thought of that being an impact crater.
Right. It's mind-blowing. And they both formed around 35.65 million years ago.
So way back.
Geologically speaking, they happened super close together.
How close are we talking?
Like 25,000 years apart.
That's a blink of an eye in geologic time. Right?
Totally.
Okay, two major asteroid impacts back to back. I mean, I'm picturing like shockwaves, tsunamis,
Oh, yeah.
global wildfires, the whole works. Right?
Yeah, absolutely. Papagai is massive.
How big are we talking?
It's the fourth largest impact crater on Earth, about 60 miles wide.
That's huge.
To put it in perspective, the entire LA basin could fit inside it.
Wow, I had no idea.
And Chesapeake Bay is no slouch either, the fifth largest.
Still enormous.
We're not talking about little potholes here. These are planet-changing events.
For sure. We all kind of have that image, right? The dinosaur-killing asteroid.
Oh, right.
That impact, that triggered a global cooling.
Exactly.
So you'd expect something similar here.
You'd think so.
Maybe even worse with Tito impacts.
Yeah.
But that's where things get really interesting.
Oh. Tell me more.
Scientists, they looked at the climate record from that time,
Yeah.
and they found something totally unexpected. What did they find when they were digging around in deep time?
Well, they didn't find what you'd expect.
Meaning?
No significant climate shifts around the time of the impacts.
Wait, what? Two asteroids hit, and the climate just cruised along? How's that even possible?
That's the million-dollar question. So, to figure it out, scientists turned to these tiny marine fossils.
Okay, tiny fossil.
They're called foraminifera.
A foraminifera.
Single-celled organisms lived in the oceans millions of years ago.
All right, I'm picturing them, microscopic fossils. How can something that small tell us about the global climate millions of years ago?
You'd be surprised.
Okay, I'm listening.
It's all about isotopes.
Isotopes.
Remember those from, like, chemistry class? Different versions of atoms?
Maybe vaguely.
Well, the ratio of certain carbon and oxygen isotopes in these foraminifera, it acts like a teeny tiny thermometer.
Really?
Recording the ocean temps way back when.
So each one is like a little time capsule.
Exactly.
Holding a piece of climate data.
Millions of years old.
That's crazy cool.
Yeah.
But you said they didn't find any major climate shifts.
Right.
What did these little fossil thermometers tell us?
Well, over 1,500 of these fossils were analyzed.
Wow, 1,500.
Yeah, and they were extracted from this rock core drilled under the Gulf of Mexico.
Okay.
And the data shows some warming, but it was about 100,000 years before the impacts.
So nothing that lines up with the impacts themselves.
Nope.
That's wild. Two asteroids, and the planet just kept on going. But how do we know for sure those impacts even happened? Wouldn't erosion, over millions of years?
You're thinking it would wipe away the craters.
Yeah. Is there a smoking gun?
There is. We found microscopic fingerprints.
Microscopic fingerprints?
Yeah, they're called microspherules.
Microspherules, okay.
Tiny droplets of silica.
And these were found where?
Same rock core as the foraminifera fossils.
So are these like teeny pieces of asteroid shrapnel raining down after the impact?
Exactly, and that's the proof.
That these impacts actually happened.
When an asteroid hits, the heat is unbelievable. It vaporizes rocks, especially the silica-rich ones.
Okay.
And as this vaporized silica cools down, it forms those tiny droplets. Yep. And they settle back down to Earth, leaving a record of the impact.
Wow. It's amazing how scientists can figure out these ancient events from such tiny clues, like some serious detective work.
Definitely.
So we have these massive impacts confirmed, but no climate apocalypse.
Nope.
What does this tell us about how stable Earth's climate really is?
It's a good question.
Is it possible the planet's even tougher than we thought?
It makes you wonder. It's a real head-scratcher, isn't it?
It is. You'd think those impacts would have messed up the climate.
You'd think so, right. But scientists are digging into it, trying to understand why Earth seems so
Resilient.
resilient. There are a few ideas out there.
Okay, so what are we thinking? Why didn't these impacts cause the kind of climate chaos we see with, say, the dinosaur extinction event?
Well, one idea is that it's all about the rocks.
The rocks at the impact sites.
Exactly. See, types of rocks, they vaporize differently.
Yep.
Some rocks, they might produce less dust and debris when an asteroid slams into them.
So less stuff blocking out the sunlight.
Right. And that means...
less of a nuclear winter effect.
Bingo.
So it's possible these Eocene impacts, they hit the right kind of rock, so to speak.
It's a possibility.
Less dust, less cooling, climate stays stable.
Makes sense, right.
It does.
Yeah.
But there are other ideas too, right?
Oh, yeah, there's another thought. Maybe the Eocene climate itself was just different.
Different how?
More resistant to change. Think about ocean currents or atmospheric circulation patterns.
Okay.
Maybe they were set up in a way that could buffer against the impacts.
So like back then, Earth had a stronger immune system.
Huh. I like that analogy.
It could fight off the fever.
That's a great way to put it.
Man, it makes you wonder, if we could crack the code of those ancient climate systems,
Yeah.
could we learn something to help us deal with climate change today?
That's the million-dollar question. It's definitely worth looking into. This whole thing really highlights how much we still don't know about Earth's climate. It's complicated.
And we're still figuring it out.
Absolutely. We're learning more all the time.
Okay, so we don't know for sure why those impacts didn't wreck the climate.
Right.
But does that mean we should worry less about future asteroid impacts?
That's a great question. And honestly, probably not.
Really?
Why not just assume that all impacts will be like these Eocene ones? It's not a one-size-fits-all situation.
Exactly.
Every impact is different. It depends on so many factors, like the size of the asteroid, what it's made of, where it hits,
Okay.
and of course, what the climate is like at that exact moment in time.
So we can't get cocky and say, we dodged a bullet once, we're good.
Exactly.
Doesn't work that way.
Nope. But even though we can't predict every asteroid impact,
Yeah.
can we learn something bigger from this
Yeah.
about Earth's ability to bounce back, to recover?
You mean even from catastrophic events?
Exactly. If the planet could handle these massive impacts without totally melting down,
Yeah.
does that give us some hope, even with all the stuff we're doing to the climate today? It's tempting to think that, isn't it?
It is. Like, Earth's a survivor. It can take a punch.
I get it. I really do. But we have to be careful about jumping to those kinds of conclusions.
Oh, why?
Because the Earth, during the Eocene, it was a different world.
Different how?
The continents were in different places. The atmosphere was different. Life itself was different.
So what worked back then?
Might not work now.
Well,
Exactly.
Especially with how fast we're changing the climate today.
Right. It's like we're running this giant experiment on the planet.
Yeah.
And we don't know how it's going to end.
So we're in uncharted territory.
Basically.
We can't just assume history will repeat itself.
That's the thing. We just don't...
It's kind of scary, honestly,
I hear you.
knowing we're changing the planet so much. But
What?
this research, doesn't it hint at something?
What do you mean?
Maybe there are ways Earth can adapt that we don't even understand yet.
Oh, interesting.
Mechanisms in Earth's systems.
Okay, yeah, I see what you're saying.
Something that could help us deal with climate change.
That's a possibility. I mean, there's so much we don't know about how Earth's systems all work together.
Right, it's all connected.
Exactly. And how they respond to the pressure we're putting on them.
This research is like, it's telling us to keep digging,
Keep asking questions.
to find solutions that work with the planet, not against it.
I love that. It's like a call for informed humility.
Informed humility.
We need to acknowledge how amazing Earth is, how resilient it is,
Yeah,
but also recognize our responsibility to protect it.
to find that balance.
Exactly. So what's the takeaway message for our listeners today? What do you want them to walk away with?
It really makes you think,
It does.
Earth can bounce back from these crazy events,
Yeah.
but does that make us feel better about the future or more worried?
That's a tough one. It's kind of like...
A double-edged sword.
Yeah,
Yes.
exactly. On the one hand, you see Earth taking these hits, these massive asteroid impacts.
And it makes you think, hey, maybe we don't need to sweat it so much.
Right, like Earth's been through worse, it'll be fine.
But then there's the other side of it.
The flip side.
Could make us complacent, right?
Oh, yeah. Like, Earth can handle anything. Why bother changing?
Exactly. Like thinking you're invincible after walking away from a car crash.
That's a good way to put it.
Not a good strategy.
Definitely not. And that's where the danger is. We can't just assume that because Earth was resilient in the past, It'll always be that way.
Right, right. Things were different back then, right?
So different. Think about it. The Eocene epoch, when those impacts happened,
Yeah.
the world was a totally different place. Continents were arranged differently. The atmosphere was different. Heck, even life itself was different.
So what worked for the planet back then?
Might not cut it today.
Especially with how fast we're messing with the climate.
Absolutely. We're in uncharted territory, you know?
We can't just look back and think, oh, history will repeat itself. No worries.
Right.
It's kind of freaky, to be honest.
Oh.
We're changing the planet so much.
It is a little bit daunting. But, you know, maybe there's a silver lining here.
Ugh. Tell me more.
If Earth could survive those huge asteroid impacts,
Yeah.
maybe, just maybe, it's also giving us clues
Clues about what?
about how to deal with the stuff we're facing today, you know, climate change and all that.
Oh, interesting.
By studying those ancient climate systems,
Yeah.
figuring out how Earth bounced back.
Okay.
Maybe there are answers there, you know, ways to help Earth adapt.
So it's not about giving up. It's about taking what we've learned.
Yeah.
And turning it into action.
I like that. It's about being inspired by Earth's resilience.
We need to learn from the past.
Yes.
Protect what we have now.
Yeah.
And work towards a better future.
Absolutely. We got to be good caretakers of this planet.
Stewards.
We're all part of this big interconnected system. Earth's history shows us that it can recover,
It's tough.
but it also shows us that there are limits, tipping points we don't want to cross.
It's a balancing act, isn't it?
It is. Recognizing Earth's power,
Yeah.
but knowing it's not invincible.
That's a good point. So as we wrap up this deep dive,
Into asteroid impacts and Earth's amazing ability to bounce back.
I want you to think about something. Next time you look up at the night sky and you see a meteor streaking across, remember that's a reminder
A reminder of what?
of those cosmic forces that shaped our planet.
Wow.
And that delicate balance, that makes life possible here.
It's pretty incredible.
It is. It's up to us to learn from the past, protect the present, and, you know.
Safeguard the future.
Exactly. Of this amazing planet we call home.
Well said. That's a wrap on our deep dive. Thanks for joining us.